Take me out to California. Take me out to California.
So Chuck, here's a question I often get asked. Does a network engineer have any advantage learning programming versus, let's say, a hardcore programmer or just a normal programmer who then has to try and take his programming knowledge and apply it to networking? And me being, again, the cynical network engineer, and sorry for like the double questions here, but when I look at SDN and OpenFlow, that seems to me a classic example of guys with PhDs or programming types who try and reinvent networking. So to try and summarize the question, do network guys have an advantage to learn programming in the network sphere, or do programmers have an advantage over networking guys?
Yeah, so to answer that specific question, I would say absolutely the network engineers have an advantage. So I've been a software developer for 38 years or whatever it is now. And I can tell you, software people are much happier if you just tell them, I want you to implement this X thing here, very well defined, and they can go back to their cubicle, not interact with anybody or anything, and just come back with a piece of code. They would prefer, the people that I worked with who were developing networking products quite often were more happy not understanding all the details of how the networking stuff worked and just implementing their widget, whatever that might be. I think that there's way more interest from networking people in learning a little bit about software development than there is in software people learning a little bit about network engineering. And so I think that people who have been able to acquire both skills go much further. And so for network engineering types, understanding programming is going to take you well beyond any software counterpart that there might be. Now, if we look in the future and you say, okay, well, there's some gigantic software product that AT&T or somebody wants to develop that is going to replace a large amount of networking functionality, and they need a ton of software developers in a situation like that. Might it be the case that your typical network engineer will provide the specifications and give those to the software guy to implement? I can see that happening. I've presented that as what I believe anyway is a legitimate way that things could go in the future for large software implementations of networking functionality. Now, that's probably not your typical case though, right? That's more a larger entity, enterprise, customer, whatever, developing something very large, very robust, a replacement for an attempt to replace BGP or OSPF or whatever it might be. So I think that those are the exception rather than the rule. And most of the people that are probably watching this are involved in things that are a little bit smaller scale, and consequently their needs will be more in the realm of needing to develop a little bit of software to go with their networking expertise. And for that situation, you're not going to be handing off your plans to a software developer. I think you'll be implementing it yourself, and that's why you are valuable to your employer if you have some amount of software skills.
Yeah, so that's a great point. So if you're in a small, medium business type setup, you may be the person that has to implement the automation side.
Yeah.
Even if you don't want to become a software developer full time, there are perhaps roles in very large organizations and like service providers where the network engineer has to understand what the program needs to do and needs to understand enough about programming to be able to relate to a developer type person. Is that right?
I think that's totally true. Yeah. So I do think that there's a need to have that knowledge going forward. And I'll tell you this, David, a lot of the graduate and other level textbooks that I read in university are written by guys that came into the computer science and software field from outside, your chemical engineers and your, physics guys, etc., who began to pick up development of software and ended up enjoying it enough that they just continued to do that. So I do think that, if people are apprehensive about learning software because they think, oh, I'm going to have to learn this, it's like having a root canal done or, listening to Barry Manilow or whatever it might be. It's not really that bad. And I suspect that for most people, they get into it and they say, oh, well, this is kind of fun. It's a little bit like Legos or something like that, where you actually create something and it gives you a sense of accomplishment. And that's especially true if you understand what you're doing. If you're doing, what you and I have talked about, David, which is, your basic cut and paste of code and then hoping that it works and crossing your fingers, that's not going to be personally rewarding and something that you're going to want to continue with. But understanding the fundamentals of, data structures and loops and conditionals and all the other stuff that are fun to learn, then you have that foundation. Then it becomes an interesting and rewarding thing to do, and even a fun thing to do. The most fun thing for me to do, and I've spent a lot of time doing a lot of different things at higher levels at the company where I wasn't actually writing code. The most fun thing for me to do, and the thing that I'm doing right now in my career, is just going back to writing code, because it's a very rewarding and enjoyable thing to do.
Yeah, that makes a lot of sense. So Chuck, it seems to be like a different paradigm for networking people versus programmers. The famous Facebook, or was it one of the other companies that said break often, break quickly type paradigm? We get told this, agile development thing is the future, where everything needs to be agile and you must release code before it's ready. And looking from the outside in, it seems to be that's a networker's nightmare. The last thing we want is a network to go down because of dodgy code.
Yep. Well, that's totally true. So you bring up a good point. In the software world, and this is true about your phone that gets downloaded every night, or your computer that gets updated regularly, or your tablet, or probably the registers that take your money at a Starbucks or whatever. We live in a world where updates are way more regular than they used to be. So things used to get delivered with hardware and software built into it, and you replace the software every couple of years. That was true with just about everything, right? Just the computers that run back and do your Google websites and everything. In the old days, those were not updated with any regularity at all. And so we've evolved from that to a world where things get updated with more regularity. Now, the fearful perspective, which I think you've articulated, is that things are working, you don't want it to break, and therefore, and you've seen software, rightly so, break, and so you're fearful that it will break. And I would say, it's empirical data that's taught you to be afraid of software and the fact that it can mess things up. So your fears are not unwarranted. However, I do believe that the days where networking and networking configurations were evaluated based on how unchangeable they were, I do think that those days are leaving us. And whether it's SD-WAN, SDN, data center, enterprise, because of the advent of virtualization, because of the advent of changing needs, because of the advent even of this, getting rid of net neutrality, the technical side of that, being able to adjust the level of service that you give somebody based on how much money they pay you. That's something that, it's not just greedy Americans, but it's also greedy service providers everywhere would like to make more money in order to do that. And I think that networks are going to have to become more dynamic. Now, will they become completely fluid entities like we had with reactive OpenFlow programming? That's not obviously going to happen overnight. So that's not what's going to happen. But even a company like Cisco, has a vested interest in making sure that networks stay as close to what they are today in the future so they can continue to earn as much money as they do, even they are recognizing networks are going to become more dynamic, more flexible, responding to topology changes, traffic changes, policy changes. And so whether that's just through a minor NETCONF change or whether it is through something way more drastic like an OpenFlow or maybe a P4 running in Barefoot Networks devices or whatever it might be, networks are going to become more fluid and more dynamic in the future. And the way that happens, of course, is only through software. Humans typing stuff in don't react anywhere as near as fast as automated things could. So there will be governors on networks to make sure that you don't make changes willy-nilly and potentially disrupt the network. But I do think that even in the most static, inflexible networks, there's going to have to be some acknowledgement that dynamic changes will be happening at some point in the future.
So you actually mentioned this term on the previous call. So I'll just let you flow with this, Chuck, but like you mentioned P4 again. So we've talked about OpenFlow, you've now mentioned P4, and we've also got traditional, say, routing and switching. Can you give us a brief, or if it's not brief, it doesn't matter, but like sort of a difference between, what is traditional routing versus, say, like you mentioned, reactive OpenFlow, and
right.
What is P4? I mean, and does it matter?
Yeah, so let me give you my super high-level view of things. On the one hand, you have networks that are configured. So you have a configuration file that gets downloaded to the device, or you have a configuration file that exists on the device that is locked down until somebody does a CLI command and makes a change. That's kind of the way that things work today. It has the advantage of being unchangeable. If it's working, then it's not going to change its behavior necessarily. But it has the disadvantage of not being able to adapt to changes in the network. And probably the best example of where you need things to change is in the data centers with all the virtualization software. Somebody does a vMotion of a VM from one physical server to another, and you need to change the networking to go with it. So that's the most, the easiest to kind of understand example of why we kind of need networking to become more dynamic. Now, OpenFlow, and especially reactive OpenFlow, where you have packets periodically getting punted to the controller and changing the network dynamically, instantaneously, etc., was the other end of the spectrum, and that maybe was too much too soon in terms of change to the network. And we've kind of it was very big in academia. It has caught on in certain segments, like NEC has a product, Big Switch has a product, others have OpenFlow based products, so they do exist, but it hasn't taken over the world. Yeah. Cisco is promoting this API-based approach where you use NETCONF in order to make your changes. So you're basically changing the configuration, but you're doing it in an automated manner. And rather than, just reloading a brand new configuration file or making somebody manually type something in. So that's kind of in between. What is P4? P4 is basically the idea that instead of having OpenFlow flow tables where you have matches and actions, and every packet comes through this, what is a little bit archaic is the wrong word, but is more of a traditional way of dealing with packets via a table. P4 says, well, why don't we have packets come in and respond through software? And when I say through software, it's really going to be through hardware, but the way that you express things, instead of expressing them in terms of matches and actions, you express them in terms of software. And hey, here's another reason to learn a little bit about software. So you have if statements, and you have loops, and you have the traditional fundamental building blocks of software, but instead of expressing a piece of code that's running on a server somewhere, it's expressing a way of dealing with packets that arrive at the device. And of course, if that packet is not going through software, that software has gotten implemented in the hardware on the device, but instead of having flow tables and all of that other stuff at a level of abstraction like you do with OpenFlow, you have it expressed in terms of this code-like language called P4. That's my take on it anyway.
Chuck, I've heard a lot from Cisco about intent-based networking or intent-based things. Is that the same as AI, or is that something else? What is intent-based networking?
Yeah, that's kind of a different thing, David, from AI. AI is really, the machine has intelligence and is making a decision that it wouldn't have otherwise. And intent-based networking is basically this idea. Today, if I need to add functionality into the network to allow a user to connect to a resource such as a server, then I need to understand, okay, am I putting this user in what VLAN are they going into? How are they getting their IP address? Are we gonna, do some level of ACLs or policy-based networking? So I have to go through and I have to program everything on the device manually. When you get to a little bit higher level, then what has to happen is, even if you're using NETCONF or something, then you need to say, okay, well, I need to configure this protocol or this VLAN or this policy or whatever for the device. And that's really not where we want to be. Where we want to be is at a level where somebody can express their intention and the networking system will take it from there. So it figures out how to do it on its own. And this isn't artificial intelligence. It's just using its ability to translate somebody's desire into an actual set of configuration parameters or what have you on the devices. It's basically the idea of imperative systems versus declarative systems. This is what I talk about in my class a lot. An imperative system, you specify how you want the system to behave, and at the end of the day, you hope that it is behaving and doing what was the original desire. But with the declarative system, you specify what you want the system to do, and you allow the system to figure out exactly how to do that. And so we would like to get networking up to the level of, declarative or intent-based networking. And this has been around for a while. It's been discussed in academia for a number of years. The folks that gave us, OpenFlow came up with a controller that was OpenFlow-based but dealt in intent-based networking. Open Daylight followed suit with beginning to call their stuff intent-based, and now Cisco and others are all on this bandwagon of intent-based networking. The general idea is that you express what you want, that is your intention, and you let the system figure out how to do it. So if it has to configure things at layer 2, it does that. If it has to configure them at layer 3, it does that. If there's a level of security that is involved, it's able to do that as well. That's the idea of intent-based networking.
Is that similar to abstraction?
It is similar to abstraction. You have levels of abstraction all throughout networking, all throughout software development, and abstraction in general is a very good thing. It allows you to separate your different concerns or your different modules or components. If you have an abstract API, one component doesn't need to know who or how the other component down below it was implemented. You see abstraction in terms of networking devices, like OpenFlow provides an abstraction such that any device that supports OpenFlow should work with any application that supports that is written to utilize OpenFlow. If you're talking about a NetConf world, and if we're in the NetConf world where you have common Yang models shared between the different vendors, then you can have your NetConf, and that Yang model is your level of abstraction. Now, just having abstraction does not achieve intent-based networking, right? I mean, what I've expressed down at a device level, it can be an abstraction for turn this interface off, and there's an abstraction so that it works on every device out there, and you're using NetConf Yang to do that, let's say, but you haven't really achieved intent-based networking. Your intention may have been take this miscreant user off of my network immediately because you've detected that they are a threat to the network. And so the way that it gets interpreted by your intent-based interface is, hey, I need to go down and shut off the port where this user is located. Let's find out where this user is, and let's turn off their port. That would be intent-based networking.
So as an analogy, if I turn the key in a car and the engine starts, is that an idea of abstraction? Because I don't know actually what it's doing. It just works. Is that right?
Correct. Yeah. So there's common abstractions.
What is abstraction in basic terms?
Yep. Yeah. We use abstractions. There's a lot in object-oriented programming or software development that deals with abstractions. In fact, you're trying to achieve abstractions to a significant degree by hiding the complexity of what is below it. So in a car, we all know that, you have a steering wheel, and that helps you to turn the wheels of the car to help you to drive. There's the gas pedal, there's a brake, there may be a manual gear shift. Those things are all abstractions, and how they get implemented by Honda or Toyota or Lamborghini for you, David, or a Range Rover or a Yugo, they all kind of work the same. And if they're implemented correctly, then they know to put the steering wheel and all of that stuff on the left-hand side of the car like we do it, rather than on the right-hand side like you guys do it over there. But I'll leave that for right now. It is an abstraction, and that's a good example of an abstraction. Now, if you wanted to take it to the next level, what would an intent-based car be? An intent-based car would be, I step into the car and I say, please take me to the grocery store, and it turns on the car. It backs me out of the garage without running anybody over. It uses Google Maps or whatever to navigate me successfully to the supermarket, and I'm there. So that's kind of showing you the difference between abstraction and intent-based operation of things.
Yeah, so like in today's networking, I as a network engineer are actually having to go and turn the wheels and do all the hard work, whereas intent-based, I just tell it what I want to accomplish and it just magically happens, kind of thing.
Yeah, I would even say that it's worse than that in networking today. You kind of have to crawl through the steering wheel column and go down to the tie rods and actually yank on that thing in one way or the other. And it's going to be different depending on whether your car is front wheel drive, back wheel drive, Honda, Yugo, or like you, David, Lamborghini, whatever it might be.
That's a great example. So abstraction is kind of like hiding the complexity in the car,
Yep.
but intent-based networking is kind of like Well, Tesla aren't there yet, perhaps, but I mean, this whole idea that I just tell the car I want to go somewhere and it just makes it happen, kind of thing.
Correct.
Is
Yep.
that right? Yeah.
That's
a great analogy, that. Chuck, I don't know if we've got time. I wanted to talk about SD-WAN, but perhaps we'll leave that to the next one. What is a Yang model? Because you've mentioned that a few times.
Yeah, so a Yang model is like an SNMP MIB. So Yang is the language by which you define your data, and the Yang model is the actual data. So you would have a Yang model for routing, you'd have a Yang model for interfaces, a Yang model for system information. That's what Yang models are. And today we're making progress towards having common Yang models. The next step, now that we've gotten closer to defining them, is for the vendors to implement them in a common way so that you can write a NetConf and Yang application that works with a Juniper device or a Cisco device or an HP device or an Alcatel-Lucent device or an Arista device or whatever. Whoever supports NetConf and that Yang model, you can treat in an interchangeable manner.
So Yang model is like a MIB, and NetConf is like SNMP, a protocol. Is that correct?
It is, yep.
Okay,
and the
great.
distinction I always try to make is that Yang in and of itself is like SMI, which nobody's heard of. It's just the language by which you define the MIB, and the Yang is the language by which you define the Yang model. So if a vendor comes up to you and says, hey, we're interoperable and interchangeable because we support NetConf and Yang, the next question you need to ask is, yeah, but what Yang models do you support? And if they only support their own proprietary Yang model, that means that if you write an application to use it, you will need to rewrite that application if you have multiple vendors, or even within a vendor. Cisco today has different Yang models depending on whether you're dealing with an XR device or any of their other devices. They all have their own Yang models.
So it's like a proprietary MIB as an analogy then?
It's entirely exactly a proprietary MIB. Yep.
That's great. So Chuck, I want to thank you again. We've run out of time, unfortunately. Thanks so much for this call and
No
for
problem.
sharing your wisdom and your knowledge. It's fantastic.
Such as it is, yep.
So everyone, once again, please send me tweets on Twitter if you have questions to ask Chuck. Chuck and I are hoping to continue this series. Let us know if this is beneficial, and we'll try and do that. And again, thanks very much, Chuck, for your time.
You bet. Thank you, David.